Moving right along, we're to the Petro and Jolliff talk. Site within South Pole-Aitken Basin for future land admissions, a case for one or more missions to the interior of the basin. And according to the program, Brad is giving the talk.
Thank you, Clive. I'm here. Can you hear me
All
okay?
right. Yes, we can.
Yeah, Tim, I love your Aristarchus sites. And when we finally can get comms for far side communication and far side missions, we'd like to propose, again, a campaign of missions, more than one, to South Pole-Aitken Basin. Next slide. Why South Pole-Aitken Basin? Well, the objectives that I list here are right out of the current decadal survey. And let me just very briefly say, chronology of basin forming impacts and constraining the period of late heavy bombardment. The whole chronology of South Pole-Aitken Basin is really critical to elucidate. The nature of the moon's lower crust and upper mantle, Dan talked about this, characterizing a large lunar impact basin by getting some ground truth, which will enable a whole bunch of remote sensing data. And then looking at the sources of thorium and other heat-producing elements. Again, Dan talked about this. I don't need to talk about it more. And finally, determining the ages and composition of some far side basalts. Next slide, please. So in addressing these objectives, we've made the case in the past that a single mission, a New Frontiers class mission, with sample return could address all of these decadal survey questions. But if CLPS would afford us the opportunity for a campaign of missions, we could get a series that would include perhaps an in situ mission and a sample return mission, interior of the basin, and possibly an exterior of the basin mission as Dan proposed. So, and that would address a couple of those objectives. Next slide, please. So sites to address these objectives, here are a number of interior sites. We focus on the interior of the basin because this is where we're most likely to get materials that are from the SPA impact melt sheet. Lots of big impact craters in there, but they have all excavated impact melt materials from SPA. So sites near Bose and Baba or Alder crater for these materials would be great. There are many possible locations in the interior of the basin. Of course, we look at geologic criteria and we can narrow that down, but many sites and large sites. Two in particular that we look at, the interior of the basin for impact melt materials, the rim of the basin for ejected deep materials. In situ measurements for geochronology, potentially in locations where we have a simple target like Mare basalt or a small basin where we might land and get chronology, and of course geochemistry everywhere. Next, please. So required capabilities. Large landing areas are acceptable. We could land with an accuracy that we think is going to be achievable with CLPS, 100-meter landing circle, then this could provide pinpoint accuracy for avoiding small hazards such as craters. We could also use terrain relative navigation, not really critical though. Data and communications for far side relay and far side ops. Yes, Dean Epler, we do need this. We need this infrastructure. Sample collection and sample return, required capability at least for one of these missions. The idea is to collect samples, the 4 S's, scoop, sieve, store, and secure them, and then return them to Earth. So we need that capability. And we would argue each mission should carry the capability to make in situ geochemistry measurements of regolith. I sure wish Shanga 4 had such, especially for iron, thorium, and some other similar elements. And that sounds to me like a gamma ray spectrometer. Next, please. So finally, enhancing capabilities, sample return, that's the key. Sample return, the most important enhancing capability for this mission. And that means having a sampling mechanism. To get diversity, we like the idea of digging at a location so that we can get diversity with depth. A rover for sample return mission could be useful to collect additional samples. Thank you, Clive. For one or more locations, near the lander, perhaps one could have access to nearby fresh craters to get some diversity from material excavated as in a radial traverse. Otherwise, we let the cratering process that really produces this well-mixed regolith to be the main mechanism for achieving sample diversity. And with that, let me finish. And I'll just say that for the organizers, I do have a table with latitude and longitude for those locations. But thank you very much.
And thank you, Brad.